This idea that you might have data in your systems that you don't own is a really new sort of idea. And if you're a medical provider, for example, you may have patient data in your systems. And I mean, anyone in IT would think that that's their data. Well, the law is starting to say, no, that's not your data. Verifiable credentials are often used. A good example is a driver's license. And I think it's a really good example because you don't actually own your driver's license. The state owns it. They give it to you. You have the right to use it. But if you get too many speeding tickets, they can take it away from you. It's not actually yours. And companies are having to now start to deal with this issue and get their mind around that they actually are housing and utilizing data that they don't own, that the consumer can take it away from them anytime they want legally.
Welcome to the SSI Orbit podcast, a forum where we explore the ever-growing ecosystems of self-sovereign identity. And I'm your host, Mathieu Glaude. Today I sit down with Brian Platz, co-CEO and co-chairman of Fluree, an open-source platform for data ecosystems. Now, Fluree is an immutable, temporal, ledger-backed semantic graph database that has a cloud-native architecture. We'll get into that throughout the conversation, but prior to starting Fluree, Brian co-founded Silk Road Technology, a company that grew to over 500 employees in 12 global offices. Now, in this conversation, the first big question that we talk about is what is data centricity? And why should organizations consider moving away from application centricity over to data-centric models? So we then discuss how an organization would go about architecting a design for a data-centric model. We then discuss just macro drivers that will lead to more data-centric applications being developed. We talk about why organizations don't necessarily need to own all the data that they use in their day-to-day business processes. We also discuss the Fluree product and architecture, and then towards the end of the conversation, we get into business use cases of data centricity, and we also talk about the interesting corporate structure that Fluree has put into place. Without further ado, here's my conversation with Brian Platz. Enjoy. Thanks for doing this, Brian, with me. Maybe to kick it off, I know you've been involved with multiple businesses in your life, and you are a serial entrepreneur. Do you mind just giving a bit of a background of how you got to where you are today with Fluree?
Perfect way to start. So I have been in enterprise software my whole career, which is about almost 25 years now. And in fact, really 20 of those years, I've worked with the same person, Flip Filipowski, who's the co-founder of Fluree. So we have been working together for some time over, multiple companies. Some of those companies have become, decently significant, especially for Flip. He predates me a little bit. And, but yeah, the common thread through all of them is really around enterprise software. And of course, one of the core issues that we end up dealing with in an enterprise software company, especially when you have to interoperate with other systems customers have, and especially if you end up doing acquisitions of other software companies, which we've done quite a few, is it comes down to a data problem. So we've really dealt with data our whole careers and data challenges. And it really seemed like a good opportunity to take some of the exciting things going on in the technology space and kind of rethink the database, if you will. And to a large degree, that is the genesis of Fluree.
What really made me interested in what you guys are doing is you're definitely playing inside the verifiable credential space, and we'll get to that later. I know that's a key kind of piece of your stack, but I know there's work that you guys are doing funded by the Department of Education. You're also just heavily involved in other applications of decentralized identifiers, and I think also just generally what really piqued my interest when we had first spoken was there's this big trend of data moving from centralized stores, of just data storage moving to the edge for privacy reasons, for security reasons. And companies are really trying to figure out like how they could change the whole mindset of today I have a data lake, or I have a big database, and I'm using this to generate intelligence for my business. How do I do that if I don't necessarily own the data, or if I'm not necessarily storing the data centrally? And so I'd be interested to just hear from you, like, and obviously the biggest companies today are all built on data. We were just talking about Amazon before we started recording. That's a perfect example of a business that's just built on data. But how would you describe data centricity? And then I guess once you describe data centricity, like, why do organizations, or why do you think that organizations need to shift away from application centricity? And maybe application centricity is a better place to start. But what are both of these, and why do you guys see the need really for organizations to shift from application-centric architectures to data-centric architectures?
Yeah, so this is a common sort of yin and yang that we like to paint, is that we've spent the last 40, 50 years in enterprise software building application-centric solutions, and that we're kind of realizing that given the needs of today and where we are today, that we have some problems. And the problems is that for our companies to survive and even thrive, we need to end up being more strategic with our data than our competitors are. And this application-centric approach has made this a challenge. Now, I don't want to be so bold to say that everyone needs, and every application needs, a data-centric approach. And I'll try and explain what I mean by data-centric in a minute. It'd be sort of like me saying that, mainframes are a thing of the past. And of course, everyone's been saying that mainframes won't be around for 20 years now. And they're still there and doing good things. So it's not a one size fits all, but data centricity is where you start out thinking about strategically organizing your data to maximize the value and reuse of your data. And then you build applications around that. So there's a whole set of standards that we endorse and we adhere to that help make that easy for organizations. In fact, verifiable credentials, which you mentioned, is actually built on top of those same standards. A lot of people don't realize that. But yeah, we think this shift needs to happen. And kind of the vision that I ultimately see, and I don't know if this will happen in my lifetime, is that right now we send our data to apps. If you use Salesforce.com, Salesforce is the app and you're always sending your data to it. That eventually we're going to flip the script, where you're going to containerize an app and be able to move the containerized app to your data, which you can house anywhere. And because it'll be able to understand what that data is, because it's strategically organized, it'll be, Salesforce, or the equivalent of it, will be able to run at your data wherever you want your data, instead of you having to move it the other way.
So when you talk about max value, like you want to generate, when you take a step back before you're looking at architecture, and it's just, I want to create max value. You mentioned reuse. Like, what are some of the key things or key decision points that one must take when they're trying to think really about what their data storage architecture needs to look like?
Yeah, I think most businesses are typically driven to action because of some external event, and there's a few of these coalescing. I mean, one of them is going to be regulation and data privacy. So that is going to force certain industries to have better organization around, your data. Things like we've had GDPR for a while, but CCPA, the California Consumer Privacy Act, is about to, actually, I think next month, they officially have the legal authority to start launching fines if a company can't tell you how they're using their data. You talk to big retail banks or big retail anything, and they have, 10 different systems, one for each business line, and they're all storing information about you, and they have no good way of coalescing them because they haven't necessarily had to. And all of a sudden, they have to abide by these regulations. So that might be one of these events. That might be one of those things that say, okay, we need to better strategically organize our data across these systems, at least for starters, so that we can comply. Another reason you might be doing this is because you're getting clobbered. I'm going through, actually at the moment, I'm going through a mortgage refinance, and I'm using a completely online mortgage broker that it was able to offer about a 0.5% lower than any of sort of the normal credible sources of getting a mortgage. And they have immense integration with everything, integration with the IRS that's automatically pulling, tax returns. Somehow they're able to validate my employment without ever calling my employer. They're able to do all these things because they've embraced, these concepts around data ecosystems, this idea that you can get strategic advantage if you can share data. So if I'm a mortgage company, if I'm starting to lose business because another company is able to better strategically leverage their data, reduce the process, then that might force me to move. So I think there'll be different types of events for different type of companies that force them into action. But I think a lot of them are sort of coming. I mean, these are some of the issues that we're starting to deal with today, and I think are just going to become more prevalent in the coming years.
I guess there's a lot of companies that do have some misconception that data needs to sit in the same place to gain value from it. And like we're in the models that we're building too, it's all about just building more like network approaches or ecosystem approaches where there's a give and take within an ecosystem. But then it means that in these data ecosystems, like not all data needs to be proprietary. You could be taking data from different sources. Some could be public, like there's public government data that's available that I could grab as well. It could be private data if we have, I guess, the relationships to do these interactions with other folks in the ecosystem. When you're talking to kind of companies about this more ecosystem approach, is there a question about kind of like who owns the data, or there seems to be this conception really still today, like the common phrase that the data is the new oil. Like I think people still think that a lot, and people invest in a lot of businesses still that are just trying to hoard data. Are in conversations you're having, do people, how easy is it for someone to switch from that one mindset to the other?
It's harder for some people, I think, than others. There's issues around data that we've never really had to have concepts of. You brought up verifiable credentials. This idea that you might have data in your systems that you don't own is a really new sort of idea. And if you're a medical provider, for example, you may have patient data in your systems. And I mean, anyone in IT would think that that's their data. Well, the law is starting to say, no, that's not your data. Verifiable credentials are often used. A good example is a driver's license. And I think it's a really good example because you don't actually own your driver's license. The state owns it. They give it to you. You have the right to use it. But if you get too many speeding tickets, they can take it away from you. It's not actually yours. And companies are having to now start to deal with this issue and get their mind around that they actually are housing and utilizing data that they don't own, that the consumer can take it away from them anytime they want legally. So I think that is, these are not things that anyone who's been in IT for a long time has ever had to deal with. So these new concepts, I think, are forcing people to think of data differently. As far as your comment, data is the new oil. One of my favorite things that I have been quoting to some degree is that Gartner is starting to say, traditionally businesses have always competitively battled on three fronts, which is people, process, and technology. Those are kind of the three pillars of differentiation. And they're now saying they believe the fourth is just getting introduced, and it's data. That is going to basically mean whether or not your business succeeds as to how competitive you can be around it. And this idea of just, companies are doing what they can, and what they can in an application-centric world is they can try and rip out all the data that they have in all these data silos and jam it into one huge data silo. But then you're dealing with other issues. One is that you've just ripped all the security out of that data, because all that data was getting secured by the apps, but you've just basically used the back door to pull it all out. And I think it's by no coincidence, actually, a lot of the bigger data breaches we've seen recently have been not from the apps themselves, but actually from the data warehouse side, when the data has been ripped out of the apps and tried to combine. And like I said, now it's just one huge silo. So it's a Band-Aid, but I can't combine my huge silo of data easily with my customers, my suppliers, which is the next thing that you have to do to get that strategic value out of it. So I think there's a lot of, we've got, I guess the bad news is that it's a really big shift, and there's a lot of work, but that's also, I think, the good news for people in IT, that I think this is really, the new frontier. This is where things are going to be made in the next 5 to 10 years.
I see a lot of similarities, like when you start talking about like where the security breaches happen. Like having spent a lot of time in just the, I guess, call it traditional identity and access management space. Like I like your analogy. You're continuously stitching stuff on top of a bad architecture to begin with, and you're causing a need for so much maintenance and data scrubbing and update. Like it doesn't seem like a sustainable approach. So you mentioned like data privacy, GDPR, CCPA being drivers for this move towards data centricity. I really do like the way you framed the driver's license is not yours either, because it could just be, you could prove that I guess you had it at some point, but it could still be revoked. But the fact that this could happen now with these new data privacy laws introduces more complexities for companies, but there's also beyond the complexities and the cost to adhere to these new and ever evolving data privacy laws, there's also kind of there's technical costs, like I was talking about with the tech debt that you're basically creating by continuing to stitch stuff on top of a bad architecture. One of the drivers, I guess, for organizations to really take the move towards data centricity seriously is just like really understanding what is kind of cost of workarounds that they're doing today.
Yeah, and I wish I could cite the source, except a good source that maybe we can come up with it and include it in a comment somewhere, is that for most companies now, about 50% of their IT budget is really spent on some form of data integration, whether it's trying to stitch two apps together, trying to map identities across multiple applications so you're not duplicating data, whether it's trying to jam all this data into a data lake. And that's 50% of the IT budget that with, as you mentioned, I think a more ideal architecture for our current time, the 2020s, could effectively not have to be there, or a big part of it is. Now, it would probably take 10 or 100 times more that in budget to just go ahead and replace every system that ever exists. And I don't know if you've lived through any of these big ERP implementations that you kind of scratch your head. It's like, how could this cost $10 million and take 5 years to implement an ERP system in a business, or even more? And it just does. I mean, there's just so much complexity and so much there. So the idea that we can just get rid of what we have and just move over to this, even if it's going to save us 50% of our annual IT budget, is sort of a pipe dream as well. But one of the things that I try to challenge people is, the first step in getting to this is stop digging the hole deeper. Put down the shovel. That's the first step, which is, as we're building new things now, it's an opportunity to actually use new approaches for the new things and allow us the time to then start moving other systems towards this sort of model. But I think it is a huge challenge. I don't think it's something that companies are generally going to be very well equipped to, flip a switch and just move over to this. It's something they have to think about. That's why I think there's probably going to be more external business drivers that are going to force action, like compliance or real fines, or a competitor that's just doing extremely well and you need to replicate their success somehow. Those are going to be probably the big drivers of this, but it is a pretty substantial, daunting task to kind of move from where we are, I think, over to more of this mindset.
I guess you guys are quite familiar too with like supply chain work that's happening as well. Like we've gone through this, right? Trying to get everyone on the same network or the same EDI or same infrastructure. It's just kind of an impossible task.
Yeah, it is. I mean, the Department of Homeland Security in the U.S., they have been focused, and I really like their approach. I mean, they've got some smart people over there, and they've basically said, hey, blockchain and all of this for proving goods and provenance, this makes a whole lot of sense. We can do a lot with it. We can be more efficient. But the idea that we're going to convince every manufacturer in the world to use one blockchain, it will never, ever, ever happen. So, their focus has been more around verifiable credentials, kind of these secure data containers, if you will, that are independent of a specific technology application, which don't require the whole world to adhere to one single system to be able to interoperate or get some of these benefits. But yeah, I think that, these efforts of everyone trying to convince everybody else to get on the same thing, it's not that it can't be done, but I think it's, if customs, which every product has to come into the country, can't force everyone to do it, then it's going to be very difficult for most organizations or associations to make this happen.
I think people tend to have misconceptions when you're using a blockchain or distributed network or stuff like that, that it's kind of you're inherently making it democratic and easy to use and adopt, but like you're really in a lot of cases you're just recreating the same type of vendor lock-in that exists in other systems, to your point, like in centralized systems, because to your point, not everyone's going to agree on the exact piece of technology, and then nor should they, right? But I guess people should be agreeing on standards, and so that's where, if I maybe just turn it down more towards now the architecture of like, I'll ask you kind of what Fluree's product and then product vision is and stuff like that. But you use standards. You use standards that come out of the W3C, for example, to do with verifiable credentials. But there's another one that I wasn't aware with before kind of digging into what you guys are doing, and it's the RDF triples, which is one of the key data structures, I guess, that falls into your architecture. What is this? Then RDF triple stands for Resource Description Framework. How do you use these standards like this to really make the model that you have in market really implementable across different tech stacks?
Yeah, and I guess it's because I don't think I ever kind of said what Fluree is, so I think it'll make a little bit more sense to answer that question if I at least give that high level context. So, Fluree is a semantic graph database that can really be deployed and distributed anywhere, that is backed by a distributed ledger, backed by a private blockchain, if you will, but a private blockchain that's very focused around storing generic data and enforcing rules and trust around it, as opposed to storing, UTXOs in Bitcoin, for example. So as a semantic graph database, or these are often called triple stores, or they're often called knowledge graphs. In fact, if you hear people implementing knowledge graphs in a company, it is inevitably a triple store that they are implementing. And a RDF is often called a triple. And so triples, the beauty of them is it's just a way of representing an atomic piece of data that doesn't necessarily have to sit in a structure like a relational database or even a graph database or even a document database. It's just this very generic way of representing a piece of information. And the triple is really quite simple. If you think of it like an Excel spreadsheet, the first part of the triple we call the subject is basically the row, the identifier for the row. The second part of the triple we call the predicate is the column. And the third part, if you could guess, is the actual value that fits into the cell. So you can think of something in a simplistic way as an Excel spreadsheet. Every single cell is a triple. It just identifies the row, the column, and then the value within the cell. Now, of course, the nice thing is that these rows and columns can have URLs, or more formally IRIs, so globally unique ways of referencing them, which is what starts to allow us to join data across multiple sources, because we now have this globally unique way to identify a column or sort of a row of data, so we could start combining them together. And of course, the cell value doesn't just have to be a scalar value like a string or a number. It can actually link to other subjects. So it's sort of like a relational database to join, but this is ultimately what allows you to create a graph. So RDF is really at its core just this very sort of fundamental way of representing any piece of data you could possibly conceive of in this very simple format.
The data then that sits within the permission blockchain, like each block has a hash, a previous block's hash, a timestamp. The data that's sitting in there, is a graph database or a triple. Is that accurate?
A triples, yeah, set of triples. So what we do in Fluree is that, if you have something simple like just something about me, about Brian, and it's Brian's first name is Brian. And I want to change Brian's first name to, new Brian. That would be a transaction, and that's going to result in two triples that ultimately get changed, excluding all the metadata, all the cryptographic proofs and all the stuff that kind of sit around it that allow you to prove that out. But the two sort of pieces of data are getting changed. As one is I'm retracting a fact that was true in our known world, which is my name is Brian. So that's one triple is basically, we extend the triple a little bit, but we basically say this triple used to be true, but as of this transaction, it no longer is. Brian no longer exists. New Brian exists. So you're asserting this new value. And in that, you're really just creating an append-only log that's just doing deltas of data changes. And those deltas are being represented effectively as triples. Again, we extend it a little bit. And then we also add new triples into it, which include things like block hashes. It includes things like, the signature, cryptographic signature that was used. It includes things if the ledger is participating with other ledgers, it might include the signatures on the block from other ledgers that help validate that they also came up with the same result for that particular data change. So that's ultimately what the ledger has. It's just this very simple append-only log. This is, in the Fluree world anyway. And then, of course, a graph database is not going to be very efficient if it needs to scan data over a huge append-only log. So we create derivatives of that log, which are indexes, which then allow us to execute queries very quickly. And then, of course, we have these database engines that can exist anywhere. In fact, we even have a JavaScript one that can run inside of a web browser, the entire database, and be fed from a ledger, at some other location. But these basically create these, in-memory databases that are able to answer queries that only have to pull in chunks of the data they need to satisfy a query. So you could have massive databases, but you're running it in your browser, you're only looking and querying for very small sets of information. It's only pulling into memory just those small sets. And then they just set up subscriptions, so they're getting constantly fed the deltas that are coming through the pipe so that they're always up to date. At a low level, we're kind of chunking up. We maintain different sets of indexes to allow you to ask different types of questions and be able to answer them very quickly, as most databases would. And we chunk up the data within an index into, about 100 kilobyte chunks. And we actually use some algorithm that allows us to organize data that's similar to each other in the same chunk. So, if I ask for, Brian's age in a query, it's going to figure out if it has that chunk of index to satisfy that. If it doesn't, it's going to go retrieve it. But then it also retrieves not only that piece of information, but a lot of similar information. So I may turn around and ask a similar query, but I now already have that data in memory. So I'm getting basically millisecond query responses from, a ledger-backed data store that I can scale to any horizontal capacity that I want. And then, we're just feeding through basically these deltas. And then every once in a while, we fill up, we call this novelty. We fill up the maximum amount of novelty we want to keep in memory. And we do a reindex kind of asynchronously. And then all these devices, once they hear about a new index that exists, they can sort of drop the deltas, because now the deltas have been folded into the new indexes. And they still typically have most of the database in memory, because only the indexes that were affected by the deltas even need to ultimately be replaced. So that's at a high level how the system works. That's a pretty technical, I don't know how technical your audience is, so I don't know if we want to get any more deeper into that. Happy to if you want.
No, I I think there's a mix in the audience. My limitations get reached at a certain point. So for my benefit and for the benefit of more business folks that are interested in this technology, this new paradigm, digital identity, self-sovereign identity, it might be interesting to just hear, now that we kind of have a general understanding of how this technology through kind of graph database or graph blockchains and the way that you're representing data and the triples and how they're linking together and how all this kind of comes together to bring the semantic graph technology. How is this being implemented today? I know that I think it's public. You mentioned a publicly known large U.S. government that you're working with, and I know that there are developers that are implementing using Fluree's technology today. From just a use case or an implementation perspective, would you be able to talk to one or two or some of these projects and kind of what the end state looks like because at the end of the day, once things get implemented, the complexity is hidden from the end user. But what are some of the interesting use cases that either Fluree or certain community members that are associated with Fluree are doing implementations now using this tech stack?
Yeah, so like I mentioned, one of the best ways to move towards this model is you put down the shovel. So that's kind of one way that we see Fluree being used is in new projects. Instead of picking, MongoDB or Postgres or something like that, there's actually an opportunity to pick a graph database that has those in many ways more capability than those, but can also be linked across data sources and sort of head down a path. So that's definitely one way. We have a very strong community of startups utilizing our open source technology to really build their apps on top of, and they get all these features. Features like time travel, the ability to reproduce, data at any moment in time instantly. In fact, you can issue a query to any previous state of your data and instantly, just as fast as current time, get responses. The ability to prove out data in history. So anywhere where there's regulatory or sort of maybe legal concerns about being able to prove what you knew when. Is another common use case. We're really big fans of this idea of these data-centric architectures. Fluree has this ability, we call them smart functions. They're kind of like smart contracts, but a data-centric view of it, if you will, that can control exactly who can transact what data and under what conditions, and it can use relationships in the data to easily determine these rules. So you can have very simple rules, but the rule, because it uses the data in the system, operates differently for everyone. For example, I can update, in a supply chain, I can update this invoice only if I work for the company that issued the invoice. So there you'd follow a couple relationships through the data that would make you be able to do that. And as soon as you're disassociated from the company, all of a sudden you lose the ability to update the invoices.
Well, so sorry to interrupt. Where do these rules, like that makes total sense that I want to, in order to conduct a transaction in a supply chain, I need delegated authority or I need X, Y, and for compliance reasons or whatever the reasons are. Do these rules and policies that they sit locally on someone's node? Is that accurate?
They're actually represented as data. So its code is data, and the data sits right in the same database and in the ledger. They effectively set in the equivalent of system tables. So if you started up a database, there's kind of like these handful of tables that are there that the database itself uses to do things. And then there's, of course, the data that you decide you're going to store. I'm going to store data about invoices, for example. So there's a set of sort of system, we call them collections, but tables that store smart function data, they store identity information, et cetera, which Fluree uses itself to then enforce the rules. So these rules are code as data, and they have the same integrity as any other piece of data, meaning if the rule is ever changed, it's a data change. And you have the cryptographic proofs of when it changed, who changed it, how it changed. If you wanted to implement a smart function that said, you can change a smart function if 3 of 5 people vote yes, you could actually implement that as a smart function. So you can actually have governance over how the rules evolve over time, built right in as smart functions themselves, controlling data that are the smart functions. But yeah, everything is sort of co-resident in the system.
Is a smart function kind of a similar equivalent of like what you would call a smart contract, where it's just assisting executing a process in kind of a trusted way?
Yeah, except it comes at it again from the other end. So it kind of flips the switch to a data-centric view as opposed to an app-centric view. So, I would characterize a smart contract as very application-centric, right? You call a method to do something on a smart contract. It's ultimately going to store some state. It's going to store data in a completely proprietary way under the hood. And 5 people can implement the same smart contract that does the same sort of thing, but everyone uses different variables, and there's zero operability between these. Now, of course, there's things like ERC20, et cetera, that force you to implement certain methods that can allow some consistency between these things. But ultimately, it's the developer of the smart contract that decides what to call every piece of data in the system. And there's no sort of standards that allow these things to interoperate. What a smart function does is it can target it multiple ways, but it can target different types of data changes. So you could say, if anyone's trying to change an invoice or update a price in an invoice, trigger this rule to validate that that's okay. If they're trying to change their name, trigger this rule that maybe make sure that the cryptographic identity is actually for the person the name's being changed. For example, you can't change someone else's name. You can only change your own name. And a single transaction may be trying to change a lot of different items in the data. And with that, it may trigger many, many smart functions with a single transaction, as opposed to a smart contract where you're triggering sort of one method that may have many data mutations underneath it. Here, you're just saying, this is the data I want to mutate. And whatever rules this is going to kick off, which may be a lot of them, validate that this is okay, it can be done.
Could you imagine, just trying to see how a verifiable credential proof request would fit into a function here? Like, would you see a smart function could basically be called and could downstream make a proof request for a verifiable credential to perform an authentication or access or whatever needs to happen? Is that how they would kind of work together? Or could a verifiable credential also be used to access a smart function?
Absolutely did both. And in fact, you could even use Fluree to implement a rule. So it can not only perform the smart functions for writes, but it can also perform them for reads. So as a user that owns my data, I could authorize my employer, say it's being run by a university. I could authorize my employer because for whatever reason, they said they need to know my GPA. Maybe I'm an intern and they have a requirement to keep it up. I could authorize that by forming a relationship with maybe only I can do to that employer, which would allow that employer to actually extract that data out dynamically in the form of a verifiable credential, except it's really sort of a presentation, because I've explicitly said this is the data I'm allowed to have come out of the system. And effectively, it becomes a just-in-time permissioned verifiable credential. So that might be another way, is not only can Fluree consume and validate verifiable credentials, and by the way, verifiable credentials are structured as JSON LD. JSON LD is a tricky way to sort of trick JSON, people who know JSON, into using RDF. So JSON LD is just RDF data. So we've been talking, it's just a serialization format for RDF data. We talked a little bit about RDF data. So if you're using verifiable credentials, you're already using RDF data. You may not realize you are. So it can not only consume a verifiable credential and validate it, it can actually create presentations of that based on permissions that the user controls. And those presentations can be sort of just-in-time presentations if you want.
For someone like DHS, who is big advocates of I guess self-sovereign identity or the verifiable credentials and the centralized identifiers. What is a use case like specifically, or I don't know if you can or want to talk about them specifically, but what is kind of a use case that you're seeing implemented right now that's using both of these types of things?
Yeah, DHS is not a customer of ours, but DoD, Department of Defense, is. And yeah, a really good example that they're focused on, which Fluree helps enable, is as a data exchange, a data sharing platform. What someone like that would rely on Fluree to help do is to prove all the data changes, so that if a data scientist or a machine or anything is accessing data that's being shared across all these different parties, that they can actually validate and know who changed what in that data when. So they have all of those cryptographic proofs. And then, as you can imagine, a lot of the data they have is also very sensitive. A lot of people can't see it, or they can see that the data exists, but they can't see these fields or these cells under these conditions. So this idea of putting smart functions in there that can control that type of granular access that they need is also present. And ultimately, the goal for all of these systems is to create a ecosystem where data can easily be shared. And maybe it's just being shared internally, maybe it's being shared between you and your partners, but there's a lot of pieces that need to exist around data to be effectively a sharing tool. And I use the analogy because Fluree works much like Git does for source code control, but for data. And just like Git for source code control really is what enabled software development teams to collaborate around source code, because they couldn't before. Like, how do I know what you're looking at and what I'm looking at if we don't have immutability, if we can't do branching? If you know, those are the things that actually enabled collaboration around source code. And for the same reason, these same features really need to exist around data when you start to distribute that control around data outside of, you know, your specific control, which you know, today for most apps in an application-centric world, the only thing that controls the data is one thing. It's the app server that sits in front of it. It controls all the writes, it controls all the reads. But this is a world where there's many writers, maybe even across organizations, and there's many readers. And that really ends up requiring a different approach to how you're managing data to support those requirements.
Yeah, and in a distributed control, distributed storage, distributed ownership kind of world, which is where things are moving more and more towards. I definitely see the scalability happening through this type of model versus I'm trying to just stick one API over the other, or just create a new policy on every single end application that I'm trying to build on top of here. And it seems like it lends very nicely to the whole zero trust ideology as well, that is quite hyped up right now.
Yeah, absolutely. And I like to think about it as that we end up through this model and through these standards, these W3C standards, we effectively have one huge global database, but the nodes containing data within this global database can have very specific controls around them. And in fact, in the case of a verifiable credential, it might be you that has control of one of those data nodes, and it's sitting on your iPhone in a wallet. But it still has this virtual link into the rest of the world and can be found by the rest of the world if they have the right permissions and capability. And ultimately, this web of data, I think, is what Tim Berners-Lee envisioned for this. Tim Berners-Lee, of course, is famous because he invented the World Wide Web. Incidentally, much of this came about in the late 60s. It wasn't until sort of the mid 90s that it really took off. He also spearheaded the standards around data, the web for data, in kind of the mid 2000s. And here we are 15 years later, and we see strong pockets of use, but it's, we're coming into the right time for all of this to start being used.
Do you see it being more like adopted more quickly by Web3 type of products? Like I know that's a focus of Fluree's. Is it a bit of an easier implementation or architecture for Web3 already kind of projects versus kind of a traditional Web2 type of business?
Yeah, I think so. We kind of have two definitions of Web3 going on depending on who you talk to. If you talk to people who came out of the W3C and semantic standards, the Web3 are these set of standards that came about in early 2000 before Bitcoin ever existed. And now there's kind of this resurgence of this definition of Web3 that's coming from the likes of, Polkadot and some of these new blockchain technologies. And ultimately, the goals are very similar and overlapping, but they're kind of two different definitions coming from two different worlds. Fluree is a little bit unique in that it actually sits inside of both definitions. Not only do we implement, the vision of the OG Web3, the Web3 of Tim Berners-Lee in 2003 era, but we also implement the vision of the sort of new Web3 kind of label we're hearing coming out of the blockchain space as well.
Shifting a bit, I know you, Fluree is a public benefit corporation, or otherwise known as a B Corp. And for those who aren't familiar with B Corps, it's a corporate structure that allows companies to hold on to their social mission. So a lot of companies that get founded off of a social mission, and it's really crucial that the social mission doesn't get lost throughout the life cycle of a company when more stakeholders get involved, or investors, or profit really becomes the main driver behind every decision. What kind of drove you to use this corporate structure for Fluree? And had you used this structure before, or kind of what was the genesis behind that decision, just out of curiosity?
Well, it's a new structure, and I guess we're not afraid of trying new things. So, that's, I think more conservative people might not have tried it. In fact, in the United States, it is still only officially recognized by about half of the states in the country. So in fact, we're headquartered in North Carolina, which actually does not recognize public benefit corporations. So we have to go by Fluree Inc. inside of North Carolina, but we're registered as a Delaware corporation, which does recognize PBCs. I think PBCs are just a fantastic corporate structure. I have, you mentioned that I've started a number of companies at the beginning and of the show. And one of the challenges that we always had is that we felt very strongly, being in the tech space even long ago, that we need to empower our employees to do good. We need to be socially responsible to our communities. These are all very important aspects to us, but as you go through venture rounds and you bring in more capital and more people are starting to look at expense lines or why are you doing this or that, it becomes very, very difficult to hold on to those ideals. And every company goes through those situations where you're hopefully doing really, really well and you're everyone's friend, and then you have a down when you don't have a leverage. And you have to make sacrifices, and you have to listen more to outside voices than you might have. And so a PBC structure allows you to just embed this directly into your corporate charter. It becomes non-negotiable. And people coming in and becoming investors need to sort of buy off on these concepts at the front end, and they need to buy off on them long term. So I would encourage any startup that feels this way about these ideals, that this is a really neat structure. It doesn't really cost a lot extra. It's not immensely more complicated of a structure over a traditional sort of corporation, but it's a great way to make sure that some of the ideals you had when you started the business can have the greatest opportunity to stay with the business long term.
So it's not necessarily about, so I guess in your charter, you could decide that I'm allocating X percentage of revenues for activities that fall under these certain ideals or these certain social values. Is that true?
Yeah, it is. I mean, a typical corporation really, outside of sort of having to adhere to following the laws, it really only has one responsibility to shareholders. And in fact, if you're found guilty of not doing that for your shareholders, you can be accountable. You can, go to jail over it. And that is returning value to them. So that is the main sort of, in a typical corporations, you are legally responsible to maximize the value you return to your shareholders. Now, of course, there will always be competing views as to how to do that, but that is what you are legally held responsible to. A PBC adds a second legal responsibility, which is the legal responsibility to, what your purpose is or what your cause is. And in fact, it actually opens up the ability for a shareholder that doesn't feel like you're following that cause or that purpose to be able to legally sue you, just like they could if they didn't think you were pursuing their best interests for a financial return. So it creates this additional legal responsibility, but it is actually baked fully into the corporate documents. So it's not something that can just be removed at a board meeting. It would require, of course, different governance might have different ways that it could be modified or changed, but effectively it requires your shareholders to be able to vote to actually change that, as opposed to something that can be decided in a budget planning meeting, for example.
Ryan, thanks for doing this with me today. I look forward to the next one.
Awesome. Thank you. I appreciate you having me.
Thank you for listening. Hope you enjoyed the conversation as much as I did. To stay up to speed with future episode releases, please subscribe to the podcast on whatever channel you're listening to it right now. If you have any questions or comments, please reach out to me directly. You can find me online. I'm quite active on LinkedIn and Twitter, so I look forward to hearing from you. See you all next time.